So we've already gone over reflections, and what we're looking at today is translations. And much like reflections, we're going to do translations both with and without a coordinate plane. The very first thing that we are going to do, though, is think about what do you already know about translations? Okay. So within this picture, when you are looking at your translation, it's going to be indicated by this vector. And a vector here is this is how you know it's a vector. That's what a vector stands for with that little like half arrow over the top. It indicates both direction and amount. So in other words, this is telling us we're going this direction and it's telling us that it's going at this specific amount. So what we're going to do, oops, not do that. Sorry about that. What we're going to do is we're going to go ahead and talk through our steps to do this translation. So the very first thing that we need to do is we need to go ahead and measure our vector from the tip to the end. And so when you look at this, from starting point to end point, my vector, according to the ruler that I'm using on the smartboard, is 6.3. And I'm just going to write this over here to kind of as a reference. And what we're going to do is we're going to go ahead and do guidelines, much like what we did with the reflections. The difference is for reflections, our guidelines were perpendicular. Now for translations, they are parallel. So what we want to do is we want to go ahead and line this up. And I'm actually going to go ahead and kind of just draw this whole line here. Notice that this vector here at the bottom is running parallel to the edge of the ruler, which means that this line that I'm about to draw is also parallel. All right, and I can extend this. You want to make sure it's long enough. And I can go ahead and measure that 6.3 along this line. And that 6.3 is going to take us right about there. And our 6.3, we can go ahead and mark that that is my new point. Okay, and I can repeat that process. The key is parallel. We go ahead and mark what we've got. And then 6.3 out, we're going to go ahead and slide this. So 6.3 along that parallel line. And again, I'm just changing colors here as I go just because that's what my smartboard is making me do. So I'm just going to go with it. And then I'm going to go down here and draw another parallel line. Okay, so all of these vectors are parallel to one another, or all of these guidelines are parallel to one another, going the same direction as that vector. So 6.3 is going to take us right about, I'm trying to be precise, but it's just frustrating me. It's going to take me out there. Let me extend this just a little bit further. It's going to take me right there. And so now if I wanted to, I can go ahead and connect the points. Don't forget to put the one at the end of the vector. I can connect those with a straight line. And I should have, when I do this, my ruler's being a little finicky here. I should have a figure that looks exactly like the figure that I started with. So I can go ahead and I can rotate this around, connect my points. And so if you haven't figured out yet, those of you guys that are at home, please make sure that you have a ruler handy to be able to be successful with this. If you need to borrow one, please let me know. I know a lot of you guys probably already have one at home. It's just a matter of finding it. But again, you will need one just to make sure you guys get the practice that you need with this stuff. A lot of this stuff, it isn't difficult. It's just a little bit clumsy, as you can tell, as I'm kind of doing the same thing here with my ruler on my smartboard. It's been a while since I've done this on my smartboard, so just kind of going with it. And so now my figure that I ended with there in green is congruent to the figure in blue. Therefore, we know it's an isometry. So again, recapping parallel lines as my guidelines. Each of my new points are 6.3 from my original. It's not always going to be 6.3. It's just that was the length of the vector in this case. All right, so we're going to have you guys practice these a little bit today, but what we're going to look at secondly is considerably easier in my opinion. It says here, translate the triangle with the vertices -3, -1, 5, -3, and -2, -2. So first off, let's graph this. Now, I'm going to be honest with you. I really am not a huge fan of this triangle. I know that sounds a little nerdy, and you'll see why here in a second. It's because when you graph this, it almost, let's see, 3, -1, it's super flat. Okay, so I got -3, -1, 5, -3, and then, oops, sorry, graphed the wrong thing. -2, -2. So it's like a really flat triangle. It almost is very, very obtuse, but you can't really see too terribly bad what's going on. So this is my D. My E is the 5, -3, and my F is -2, -2. Now notice this. It says along the vector 3, -1. Basically, you need to pay attention to your signs. What it's telling you is exactly what you see here below, that since the 3 is in the place of the x and it's positive, we're adding 3. Since the -1 is in the place where the y would be and it's negative, we're subtracting. Okay, so the vector and what you see here written that I underlined in green is essentially the same thing. Okay, so as you guys look at this, another thing that you might see this written as, it might say a rule, and it would say xy is going to x plus 3, y minus 1. So if you see something that says that's the rule, that's all it's saying. And guys, all you're doing from there is taking your values. So like for example, my d prime, I'm going to use my -3, -1. I'm adding 3 to my x value because it tells me to, so I get 0. I'm subtracting 1 from my y value because it tells me to, so that's my new d. My e value, my new e, again, I'm adding 3, so I come to 8, subtracting 1, so I'm at -4, and last but not least, my new f then would be adding 3 would take me to 1, subtracting 1 from that takes me to -3. So that's going to be my new points. So now I can go ahead and plot those. So 0, -2, 8, -4, and 1, -3. And again, we have that really flat looking triangle. But again, when you guys are doing these, your pre-image and your image should look exactly the same. This is an isometry. We do have that congruence factor in there. So those should look the same. So we are good to go. All right, let's take a look at the sailboat. It has a coordinates of 100 degrees west, 5 degrees south. So first off, think about a what's that called? A compass. Sorry for that. I had a little brain lapse. We've got west is this direction, east is this direction. We've got north and we've got south. And so if you think about it in terms of like a coordinate plane, 100 degrees west is a positive number. So it's gone, excuse me, a negative number because you've gone to your left. 5 degrees south has gone down, so it's a -5. The boat sails 50 degrees due west, then the boat sails 10 degrees due south. What's the boat's final position? So if it goes another 50 degrees due west, you would then take a look at where you started, okay? And so your final, you're going 50 degrees more to the left, so -150, and then it's going 50 degrees due west. So, excuse me, we already did the 50 degrees due west, 10 degrees due south. So then you're at -15. And so if you think about that in terms of west and south and all that good stuff, 150 degrees west, 15 degrees south. And the reason we put them in the coordinates and whatnot first is because it says what single translation vector moves it from its first position to the final. It helps us kind of process this. So we went -50 to go from here to here, and we went -10 to go from here to here. So that would be your vector that it went along. So this is our final position. And then we also have our vector. Okay. So I'm going to give you a moment to just kind of recap a little bit, kind of give me a quick summary, and then I'll give you guys some feedback on this Ed puzzle. As always, let me know how I can help. I think you guys will be fine with it. Thanks, guys.